When trying to balance a redox reaction, one of the most frustrating things might be deciding on whether you have spectator ions and how to remove them. With this simple flow diagram, we're going to look at the following half reactions and analyze each species, that is the species on the left and the species on the right, according to the flow chart to decide whether we have spectator ions present. So if we look at the first species, it's an aqueous. And the first question is the species in solution? So here the answer is yes. Does the species have a charge? No, it doesn't. What type of compound is it? This is an acid. Okay. Is it one of the strong acids that you know? Remember, there are only 7 strong acids. No, it isn't. Therefore, it's a weak acid. We do not remove the hydrogens from a weak acid. So I'm going to put a cross above the first species. Here we see gas phase. Is the species in solution? No. Therefore, it cannot be split up to make spectator ions for removal. Here we have a species in solution. It doesn't have a charge. It is an acid. And we know that nitric acid is a strong acid. Therefore, we know that we can split this into our NO3 minus ion and our H plus ion. The NO3 minus, the nitrate ion, is what we will use in the half reaction. Nitrogen monoxide gas, the species is not in solution. Therefore, you cannot remove any spectator ions. Moving on to the third example. Here with KMNO4, aqueous, the species is in solution. Does it have a charge? No, it's currently neutral. What type of compound is it? We know it's ionic. So if it's an ionic compound in aqueous solution, we may split it to remove the spectator ions. So potassium permanganate. So the potassium will be split off and removed as a spectator ion. Here you see we've got a species in solution. Does the species have a charge? Yes, it has a charge. Therefore, we are not able to further remove anything from it. Moving on again, here we've got aqueous, no charge, but it is a weak acid. Therefore, we need to keep the peroxide whole. So there's no spectator ion to be removed from there. Oxygen is in gas format, no spectator ions. Here we see a species in the solid phase, and we know that solid phase is not going to yield us any spectator ions. Here we've got a species in solution. It has no charge and it's ionic. Okay? We are going to split the species as such. Therefore, sodium will be the spectator ion in this case. Finally, let's look at the last example. Is it in solution? Yes, it is. Does it have a charge? Yes. Because it has a charge, we cannot split this compound any further. So no spectator ions can be removed from the left. Can any spectator ions be removed from the right? No, because the phase of the species is in gas. Thank you very much.